We're still in Chapter 3 doing episode number 2. This lesson is going to involve decimals and fractions. The key to decimals and fractions is it's about reading the math itself. One of the most important things when we deal with decimals is about the place value. So remember, the decimal point is very important. If you go left of the decimal, you have your ones place, your tens place, your hundreds place. But if we go right of the decimal, we introduce these guys called tenths, hundredths, and thousands. And they keep on going out as well, 10,000s, 100,000s, and millions. But we're just going to stay within this framework for our lesson. So let's look at the decimal 0.5. When I say 0.5, I really didn't read that decimal. I'm just saying the symbols on the paper, the 0.5. Reading it is understanding place value. So that's how this 5 is in the tenths place. So the correct way of reading this would be to say 5/10, which also allows me to change it to a fraction, 5/10. So if we look at this, a lot of us would say 0.25. That's not really reading it. Reading it would be to say 25, and since I went 2 places past the decimal, hundredths. So this would read as 25 hundredths. So you kind of read the number and look at place value and put that together, 25 hundredths. So 0.25 actually means 25 hundredths, which we can also write as a fraction, 25/100. So this leads us to changing a decimal to a fraction. So for instance, I get the 0.6. To change that to a fraction, if you can read it, you can do it. So if you look at this as a 6 in the tenths place, this equals then 6/10. Now, to reduce this, one way to do this is our prime factorization strategy. We have our 2, 3, 5, 7, 11. Start with our 6. We know that does 2 go into 6? Yeah, 2 goes into 6 3 times. 3 doesn't break down with the 2, but 3 goes to 3 one time. So that 1 tells me that our prime factorization would be then this 2 times 3. Then if we break down the 10, we know that 2 does go into 10 5 times. And since 5 is prime, we know 5 would go into 5 one time. So that would change into 2 times 5. And to reduce it, we can see that the 2's divide out, and our answer would end up being 3/5. So a lot of times when you have to change a decimal to a fraction, they want that fraction in lowest terms. Now if you're in my class, ask me about the calculator, and we'll show you how to also do this on a calculator. Looking at this next example, we have 12 hundredths. Again, we have the 12, 2 places past the decimal, so we have 12/100. Again, if we want to do a prime factorization, we can. So for the 12, we have 2 goes to 12 6 times, 2 goes to 6 3 times, 3 goes to 3 one time. So the 12 will break down into 2 times a 2 times a 3. The 100, we know 2 goes into 150 times, 2 goes into 50 25 times, 2's down, 3 doesn't work, 5 goes into 25 5 times, and 5 goes into itself one time. So that gives me 2 times 2 times 5 times 5. Therefore, the 2's divide out. We have a 3, and putting the 5's back together, we'd have 3/25. Now, if you're pretty good with division facts, you may be able to see that both of these guys have a divisor of 4 in them. 4 goes into 12 3 times, and 4 goes into 125 times. So you actually could do that by looking for that greatest common divisor. And if all else fails, ask me about the calculator, and we'll show you how that works on a calculator. So now let's go the other direction. Let's change a fraction to a decimal. Remember, a fraction is essentially a division problem. So our strategy really is to just divide. This is one way of doing this problem. So we actually have 3 divided by 5. So the way this works is using long division, and a lot of times we'll call it the rain game. The guy getting the rain done actually goes in the garage. So the rain's coming down on the 3. We want to cover him up and put him in the garage. So the 5 goes on the outside. But notice how 5 doesn't go into 3. We can put a decimal point here and add a 0. And 5 does go into 30 6 times. And 6 times 5 is 30, and we get a remainder of 0. So essentially we ignore the 0, right? We ignore the decimal. Just bring that up in the answer and just treat this like whole number math. Again, you can also just type 3 divided by 5 in a calculator, or there's another strategy on the calculator. Ask me about that. We'll show you how that works on a calculator. So our answer ends up being then 0.6. You kind of see that back and forth there. 3/8, again, using the rain game, 3 goes in the garage. 8 doesn't go into 3, so we add a 0, but I'm not real good at my 8s, so I may just write my 8 facts down over here to make it easier. So I have 8, 16, 24, 32, 40, 48, 56, 64, 72. Just your first 9 facts will work. 1, 2, 3, 4, 5, 6, 7, 8, 9 facts. That'll get me through my division problem. So 8 goes to 30. It looks like this 24 works. So I'll put the 3 here. Go ahead and bring your decimal up in your answer. 24 goes underneath. 24 take away 30 take away 24 would be a 6. Since I want a decimal answer, I can't stop there. What I got to do is add another 0 to the problem, slide it down into our problem, and we continue doing division. 8 goes to 60. Looks like that 56 is our best number. And that's 1, 2, 3, 4, 5, 6, 7, 8s. So 7 times 8 is 56. We bring our remainder down of 4. We slide another 0 in. And then we just do the division again. 8 goes to 40. There it is. 1, 2, 3, 4, 5. So that one ends. So if it didn't end, we would maybe look for rounding or something. Typically, most of our division problems aren't going to go out too far. That will end probably between 1 and 3 decimal places over. So we end up with 0.375 or 0.375 as our decimal number. And if we want to read that correctly, we would say 375 thousandths. So that would be out to the thousandths place, 375 thousandths. So that will help us kind of tie in a relationship between decimals and fractions. They're kind of interchangeable. Stay tuned for another lesson.